Let's start. Okay, for last week, we started with group 17. Just a very quick global recap. For group 17, we call it as halogen. Alright? So for group 17, you must know the first four member. Okay, you must know the first four member. So the first four member in the group 17, they are fluorine. They are chlorine. They are bromine. And they also iodine. The symbol is F, Cl, Br, and I respectively. So the electron arrangement of fluorine is 2.7. Chlorine, add one more circle, 287. Bromine, one more circle, 28, but 18.7. For your level, you don't need to know what is 18. Iodine, one more circle, 28 double 18.7. Okay? So that's it. And you must know what's so special for group 17. They are very, very different states. Fluorine is a gas, and the color is kind of like pale yellow. Okay, you have a pale yellow color. It's a yellow color gas. Chlorine is a greenish yellow. Okay, chlorine is a greenish yellow color. It's still a gas. Bromine, meanwhile, already became a liquid, and the color is approximate brown. Iodine is a purple, black color. Purple makes black color solid. So you must be able to see a pattern or trend. Going down the group, you can clearly see that the color is getting darker. Going down the group, you can clearly see that the gas slowly becomes solid. That's the trend you must know. Second thing, what else we learned from last week? Just a very quick global recap before we go on. We also learned that group 17 always appear in diatomic molecules. Okay? Group 17 appear as diatomic molecules. So diatomic means that group 17 always come in two pieces. Okay? Cl2, Br2, F2, I2. All the group 17 always come in two pieces. That is called diatomic. Okay? So what else we learned? We learned most of the concepts already. Okay? So today we will focus on something much more crucial. Okay? We also learned a very important thing from last week called reactivity. Fast forward to here. Reactivity. So for reactivity, what is the important thing from last week? You all must know. All the group 17 substance. All group 17 substance. In the other word, all halogen. All the group 17 substance, they have 7 outer electrons. All of them have 7 outer electrons. So the first question to be answered, are they stable? Not yet, right? 7 outer electrons is not fully occupied yet. They are not stable. So they are not stable. Okay, they are unstable. So when they are unstable, they want to be stable. What they do? They go to take electron. So all the group 17, they will prefer to do this. They will prefer to receive. You can use the word receive. If you don't like it, you can use the word gain. You can use the word accept. Either one. They will receive, gain, or accept one valence electron. Okay? They will accept one valence electron in order to be stable. They will achieve stable electron arrangement. Again, guys, just in case if you all forgot, what is stable electron arrangement? The outer shell fully occupied, so-called duplex, so-called octet. So far so good? Alright? So make sure you all know. Okay, a simple tips I can tell you for reactivity is that for group 17, the reactivity is totally opposite of group 1. Okay, this is the simplest thing can help you a lot. Group 17 reactivity totally opposite of group 1. Make sense, ma? Because if you recall back, group 1, how you achieve stability? Throw 1 electron. Group 17, how you achieve stability? Take 1. Understand? Just opposite. Group 1 throw, group 17 take. Yeah? And what happened to reactivity? We learned from last week. Group 17 reactivity depends on how easy to receive electron. Group 17 reactivity purely depends. It depends on how easy, okay, to receive the electron. So the more easily to receive electron, the more reactive it is. Okay? The more easy to receive electron, the more reactive. So more easy to receive electron, so you become more and more reactive. So last week, what we have covered here, if you compare, we choose 2 for comparison, fluorine, 2, 7. Let's say go all the way down to the last color, iodine, 2, 8, 18, 18, 7. The same one. So fluorine got 2 circles, 1 and 2, 7 electron at outside. Iodine got 5 circles, 1, 2, 3, 4, and 5. And then you also have 7 electron at outside. 1, 2, 3, 4, 5, 6, 7. So when you have 7 outer electron, you want to receive 1 more. So there is an electron outside here, you want to pull in. There is an electron outside here, you want to pull in. Again, to be 8. Electron pulled by who? Center. The center here called nucleus. Okay? So the nucleus is the one who pulling the electron. The center, the nucleus, is the one who pulling the electron. Remember, don't use metallic bond, don't use van der Waals. Huh? Metallic and van der Waals is all for melting or boiling point. So far so good? So the idea is very simple, a simple common sense. If you compare, F only have 2 shells. But if you look at iodine, you have 5 shells. So in this case, when you have more and more shells, when you have more and more circles, the electron far away from the center. When electron far away from nucleus, the pulling force is very weak. So it's very hard to pull that electron. So for group 17, when you're going down the group, it becomes harder and harder to pull in the electron, so it becomes less reactive. Understand? So that's why going down the group, it becomes less reactive. As simple as that. And this is where we stopped last week. Are you that? Okay, let's continue from here. Okay, so today we will only touch another 2 more concepts. Huh? Okay, so today we will touch 2 more concepts. The first thing we will touch today is called chemical properties. Huh? Today we will learn chemical properties of group 17. Okay. Okay, let's start. Okay guys, group 17 can react with 3 fella. Group 17 can react with water. Group 17 can react with water. Group 17 also can react with sodium hydroxide. I'll tell you what is it later. Don't worry, we go slowly, one by one. Last one, group 17 also can react with a hot iron. So there are 3 things here. Okay? So one by one. Huh? So I'll show you what is happening. The first one is the most important one. So please pay attention. If you have any problem, ask me. Huh? Okay, the first reaction is react with water. The first one is react with water. Okay? So, guys, by me saying that, I say group 17 is the rival of group 1. They totally opposite. If you all remember, can group 1 react with water? We learned that before, right? Group 1. Group 1 is alkali metal. If you throw alkali metal in water, they make the water become alkaline. It becomes alkaline. That's it. So group 17 totally opposite. Group 17 also can react with water, but I'm opposite than you, ma. You make alkaline, I make acids. Understand? Simple as that. Alright? Totally opposite. Okay? So when the halogen, when group 17 go on to react with water, so you will actually form acids. Why I put S here? Because you form 2 acids. You form 2, not 1. Group 17 always love to come in 2. That's why group 17 is diatomic. Di stands for 2. Here? Okay, now I teach you how to write the equation, and please don't memorize. Okay? Like what I say, the tips is that always use somebody to predict. Okay? Chlorine, bromine, iodine. You choose a fella you feel more familiar to predict. For me personally, I love chlorine. Okay? I think I feel more comfortable with chlorine rather than bromine and iodine. Okay? So my tip is that I will prefer you all use chlorine to do prediction. You use the chlorine to do the prediction for the chemical equation. Once the chemical equation is predicted, then you can do the copy paste, okay? You can copy paste for another fella for your bromine and also iodine. That's the one, okay? We did that for group 1 as well. Group 1 we use sodium, okay? Now follow me. This is a chlorine. I teach you how to do this without memorizing. Chlorine plus water. You want to form acids. Okay, you will learn this in your Form 4 Chapter 7, but for me, let me teach you now. Acids always start with H. I repeat, acids normally start with H. Let me give you some simple thing first. You will learn this in the Form 4 Chapter 7. You see, nitric acid, I asked you to memorize in Chapter 3, HNO3. Sulfuric acid, if you really good to memorize, formula H2SO4. One more super famous acid, hydrochloric acid. Hydrochloric acid, every formula, HCl. What you see in common? All the acid, they started with H. Understand? So you want to form two acids. So you must start with H. Okay? So any acid got H, and then here you can see Cl. You see Cl, I think hydrochloric acid. Are you with that? Hydrochloric acid, as simple as that. Okay, the second one, I teach you how to do the second one. The second one, just copy and paste. Write one more, HCl. Okay, just copy, paste, and add an O at the back. That's all. HClO, that's all. So you form two acids already. Understand? Okay? And it's balanced. You check yourself. You got 2 chlorine on the left, 1 plus 1, 2 chlorine on the right. You have 2 hydrogen on the left, 1 plus 1, 2. You have 1 O on the left, you have 1 O on the right circle. Clear? That's how we do. HCl is the acid, another one acid, just add 1 O, HClO. Some of the book, they write as HOCl. Doesn't matter. HClO, HOCl doesn't matter. You write O first or you write Cl first, doesn't matter. Are you okay with that? So when you put the chlorine into the water, you will form 2 acids. The first acid is called HCl, hydrochloric acid. The second one is HClO, it's called hydrochlorous acid, which you don't need to know how to do. Okay? Now, after you write this equation, can we copy paste? Yes. Let's do the copy paste action. So we will copy paste for the 2 further, bromine. Copy paste. Bromine is Br2. So when you put Br2, water, copy. H, copy. Just now you use Cl, now you change to Br, HBr. Same thing, just now H, just now you use Cl, now you use Br, HBrO. Or even HOBr is okay. You can see how it works? Alright, last one. How you copy paste for iodine? Iodine I2. So, same thing, water, copy. Then what you're going to see here, H copy, Cl, Br now change to I. Okay, same thing, H copy, Cl, Br now change to I. And here the O copy. Okay, again, you can write HIO or HOI. It doesn't matter. So far, so good? Okay. So this is how are you going to write your first equation, reaction with water. Understand? Okay, now I will show you a simple experiment. How this question can be tested. Okay, what you need to know. Okay, we should know the experiment observation. Okay, so we all must know the observation. Okay, for this experiment. Okay, I will show you 3 experiments on the whiteboard and how it makes sense to you. The first one, I have a water. This is a test tube. Inside got water. Okay, everyone, this is another test tube. Inside got water. This is another test tube. Inside got water. So again, don't memorize too much. Let's use some common sense. Okay guys, I want to do 3 further, chlorine, bromine, and iodine, and I want to hear from you. That's the first further called chlorine. You can check your notes, no problem. Can anyone volunteer to tell me what is the states of chlorine? States, solid, liquid, or gas? Gas. Chlorine is a greenish yellow gas. Normally, how you channel a gas, like when you get in BD3, how you flow like carbon dioxide in lime water. You have a straw or you have a delivery tube. Okay, can be straw, it's okay, right? But the proper one called delivery tube lah. Okay, so this fella called delivery tube. So delivery tube will help you to deliver or channel the gas. Understand? So your chlorine gas will be flowed into the water. Does it make sense? Okay, huh? Alright, what about here? Everyone, what about this fella? The second fella is bromine. Guys, bromine, solid, liquid or gas? Bromine. Liquid. You check your notes. Bromine is a brown color liquid, okay? Bromine is a liquid. So liquid, do you need a tube like this? No need. So just pour in. You can just take a dropper, you put in your bromine. Understand? Just take a bromine liquid, just drop in. So this is your bromine liquid form. Okay, last one. This fella go for iodine. Guys, check back your notes. Iodine appear in what form? Solid, purple, black, solid, right? Solid, you don't need to do this, right? You cannot drop a solid inside. Solid, don't need to use a tube. Solid, just put in. So you just put in directly and the solid will sink at the bottom here. Understand? So far, can you see what happened? I'm trying to do the experiment with you all. These are all the water. I'm trying to put all the halogen into the water. So you can imagine what is this experiment all about. Clear? Okay, now, what you will expect it will happen, guys, a quick revision from last week. A quick revision from last week. This is chlorine, bromine, and iodine. Group 17 going down. Guys, a quick revision, I want to hear from you. Group 17 going down. More reactive or less reactive? Less. Group 17 go down is less. Group 1 is more. Clear? Group 17 go down is less reactive. Very good. You must have this thing in your mind. Less reactive means what? You will expect the reaction become less and less vigorous. Understand? Okay, how to make it less and less vigorous? I give you an example. Chlorine go into the water will dissolve. You see? So in this case, chlorine gas will go in and dissolve. Chlorine gas dissolve. Magic words. Very quickly. Okay? It dissolves very quickly. Okay? In the water. So what about this? Bromine. So when we have a bromine liquid not as reactive as the chlorine. You still dissolve though, but you cannot say very quickly. Make it a bit lesser, maybe quickly. Understand? Alright? So bromine liquid dissolve quickly in water. In contrast, what about this? Iodine. We know iodine is the lowest one. Iodine is the least reactive. So if you are very quickly, this one should be slowly. Understand? Alright? So iodine solid should still dissolve, but it will dissolve a bit slowly in the water. So can you see the difference so far? Not hard, right? Get it? So I want you all to see the comparison to not become less and less reactive. Okay, what is the final solution here? What is the final solution? We all know that when halogen go with water, you form two acids. Which means all the solution here is acid. How you prove they are acid? Litmus paper. What do you do? Blue. Understand? Alright, so all the solution for this, okay? The blue litmus paper would all the way turn to red. So your blue litmus paper will turn to red to prove that it is acidic. This one, your blue litmus paper would also turn to red. So that proves to you that you are making some acids. Understand? Can you see it's opposite of group 1? Group 1 upon dissolve you form alkali. That's why the litmus paper red to blue. So just the barley only, just opposite. Are you okay with that? Okay, last thing before you jot down, I want you all to watch out this. This is a bit special. Okay, I want you all to know, this is extra knowledge. Put 3 stars here, very important. Okay, I want you all to know, chlorine and bromine, they can be bleaching agent. Chlorine and bromine, they have a bleaching power. They can be a bleaching agent. Guys, what is bleach? A special chemical, they will make the color fades away. Okay, guys, remember only two further can be bleached in group 17, chlorine and bromine, which means to say, after you put the litmus paper blue to red, which is okay, no problem. Eventually, after the litmus paper from blue to red, in the end, it will actually got bleached to white. Okay, the whole litmus paper become white because the color is bleached by the chlorine. Understand? Same thing go for bromine. After the bromine dissolve in water, yeah, all the halogen dissolve in water, you will form two acid. Yeah, all halogen form two acid. But for the bromine apart from being an acid, bromine also a bleach. So after blue litmus paper turns red, which prove they are acidic, they will eventually make the litmus paper bleach all the way to white color. So you all have to be careful here. Got it? Chlorine and bromine, they have bleaching power. Now iodine don't have. Iodine dissolve in water, perfect. Iodine form two acid, perfect. Litmus paper red to blue, that's all. So blue to red, okay? And then it won't bleach because iodine don't have that additional bleaching power. Are you okay with that? So this is what you need to know. Any question? Okay? So I hope you all can see what is happening here. Alright? So a quick verbal recap. We are learning the first reaction. Halogen react with water. When halogen react with water, you form two acids. Two, not three, not one. Two acids. You always use chlorine to create your equation, and you modify the equation become bromine and iodine accordingly. So how you predict acids? All acids got H. So when chlorine react with water, you know you get two acids. The first acid must have H. So you put the H and you saw there's a Cl. Make it HCl, hydrochloric acid. The second acid, just copy paste the whole thing and add O. That's all. Here, that's how you create the second acids. You got it? Okay? So this is the experiment, and I want you all to clearly see that the reactivity getting lesser, right? Dissolve very quickly, dissolve quickly, dissolve slowly. Because group 17 going down, the group become less and less reactive. Okay? So this is what you should know. Jot down this. Okay guys, we have covered the first reaction. So let's learn the second reaction. So second reaction, now I want the halogen all the way to react with sodium hydroxide. And guys, for your information, we learned last week, sodium hydroxide is NaOH. In chemistry, anything got OH is alkali. Okay? So I agree with that. Guys, now we are going for the second reaction. The second reaction, what we want now? I want the halogen to react with sodium hydroxide. I want to remind you, sodium hydroxide, the formula is NaOH. I want to remind you, sodium hydroxide is an alkali. Alright? So now, sodium hydroxide is an alkali. Hey, how come you can react with alkali one? Makes sense, guys. We learned just now. If you remember, we learned a moment ago. Halogen, they are acidic. Acid can react with alkali. Understand? Acid can react with alkali. The process is called neutralization. You will learn in more detail in Form 4, Chapter 7. Are you with that? I repeat that. Halogen, they are acidic. So they are able to react with sodium hydroxide, which is alkali. Acid can react with alkali. Understand? So when acid react with alkali, what happens? Halogen react with sodium hydroxide. Okay? Halogen, when you react with sodium hydroxide, alkali, you will able to form. Okay? You will able to form two salts. You will form salts and also water. You form two salts and you form water. Okay? When halogen react with the sodium hydroxide, you form two salts and you form water. Same thing, please try to use chlorine to do your prediction and you copy paste accordingly. Now, let me show you how I play with chlorine. Everyone look at here. Okay, I have chlorine. Everyone do it here. Chlorine. Okay, chlorine is Cl2. Okay? So chlorine is Cl2, react with sodium hydroxide and NaOH. Okay, now I want to form two salts and water. Okay, two salts and water. The first one, can we predict the salt, guys? What is the most famous salt that you know? The salt we are eating every day is called sodium chloride. Do we know the formula for sodium chloride? I think so, right? NaCl. True not? So you successfully get one salt, right? Now, how to get the second salt? You can use the same way how we cheat for the acid just now. How to get second salt, everyone? Copy paste and add a O. You get the idea? Just copy paste and put an O. That's all. That's how we do. You got me? Copy paste, put an O. That's all. Just like just now the acid HCl, one more acid HCl, add one O. You got me? Alright, that's how it works. Again, NaClO or NaOCl doesn't matter. So you don't feel panic or started the question you NaOCl is okay. It's the same. And don't forget, guys, apart from getting two salt, you also have water. If you don't put water, you cannot balance the equation. Okay, let's balance it. Chlorine got 2. Chlorine got 1 and 1, 2. That's good. Sodium got 1. Sodium got 1 plus 1, 2. Not good. Put a 2 here. Oxygen got 2. Oxygen got 1 and 1, 2. That's good. Hydrogen got 2. Hydrogen got 2. Perfect. That's how we do. You got me? After that, you know what to do. I mean, you are good with copy paste, I think. Alright? So just copy paste up. Okay, just copy paste. Bromine, copy paste 2 NaOH. This one become Na. Cl become Br. This one Na, Cl become Br. O and H2O. Yeah, that's it. Copy paste. After that, iodine, react with sodium hydroxide. Copy paste. Number 2, still copy paste. This one Na. So now Br become, now you use iodine, change it to I. Now Na. So when you use iodine, change the Br to IO and H2O. And that's how easy it is. You got me? This is called prediction. Don't memorize. Understand? There's a lot of people that memorize and they just don't find a way. Okay? They just don't find a way how to do that. So don't need. You can just do a prediction. Okay, last one is this. Experiment. So your experiment, just modify a little bit only. You just modify a bit, you get the experiment already. Yeah? Okay. So guys, your setup, the setup is exactly the same. We only change a bit. Everyone look here. How to be smart, you don't need to memorize everything, just do here. Now, chlorine, bromine, iodine, still the same. Still the same. This is iodine solid. I forgot the label just now. My bad. My bad. Okay? This is iodine solid. Okay. The first reaction, we want them to react with water. That's why water, water, water. Now guys, what we want? We want to react with sodium hydroxide. So change the water become sodium hydroxide. Change the water to sodium hydroxide. Change the water become sodium hydroxide. As simple as that. Same thing. No matter water or sodium hydroxide, when halogen go in, they react. When they react, they dissolve. Still the same thing. Very quickly, slowly, the same. But here a bit different already. You see guys, just now we write litmus paper blue to red, bleach to white because we form 2 acids, right? Everyone look back here. In this particular scenario, when halogen react with alkali, sodium hydroxide, what do you form? Salt and water, right? Guys, is salt acidic or alkaline? No, right? Salt is not acidic, salt is not alkaline, salt is neutral. Okay, I want you all to learn from now. Salt is not acidic, salt is not alkaline, salt is neutral. Okay? So you form a neutral thingy. So when you form neutral thingy, what happened? Litmus paper here, no need. Just remove the litmus paper. Just remove the litmus paper. Just remove the litmus paper here. Okay? Simple as that. Are you feeling that? Alright, you don't need to change color because you form something neutral, right? Neutral, you shouldn't use litmus paper no matter red or blue. Okay? And what is the color of the final solution? Okay? Just imagine today if you take something acids, put in something alkali, you form the salts and water. Guys, what is the color for salt water? Today, if you take water, you pour in some sodium chloride, you put some salts in the water, make a wild guess, what color you see? Colorless, right? True or not? Don't say white, something wrong, okay? Colorless, okay? Today, imagine guys, okay, I'm trying to give you an idea what is the color for the salts, because why? Our final product is salts and water. Today you take the salt you are eating, sodium chloride, white color, solid, put in the water, stir. After stir, what is the color? Colorless. Understand? So all of them, because you form salt and water no color. So you form colorless solution. You form colorless solution. And you form colorless solution. Okay, this is what you need to know. Any questions so far? So this is the second reaction, okay? So when you take halogen, react with the sodium hydroxide, halogen is acidic. It can react with the sodium hydroxide, which is alkaline. Acid plus alkali, they will produce salts and water. You produce two salts again. Why? Because group 17 is diatomic. They love two. They love two. Here. So this is how you write your equation. I hope you understand how to do it without memorizing. And then this is the experiment. Okay? Not very hard. Huh? You guys do remember the second one. This is quite similar as the first one, okay? The only difference is that just now, the first one, halogen dissolved in water. Now you dissolve in sodium hydroxide. And the outcome a bit different. When halogen dissolved in water, you form two acids, and that's it. So when halogen dissolved in the sodium hydroxide, aka alkali, you form two salts and the water. Alright? So make sure everyone know how to get the formula for the salts and the water. Okay? So this is the one. So do remember, modify a bit just now. The water here, please change to sodium hydroxide because you no longer dissolve in water, but you dissolve in sodium hydroxide. But it's the same thing, okay? Very quickly and slowly to show that going down the group, it becomes less and less reactive. Last one, the third one and the last one. So let's go for the third one and the last one, which is react with hot iron. React with hot iron. Okay, so this is the third one and the last one for group 17. Then we will finish off with all the groups already. Okay? So the last one is that you will react with hot iron. Okay, this is a bit technical. Please listen carefully and go on with me. Okay, first of all, when we have halogen, which is group 17 further, halogen can react with the hot iron. Okay? Sometimes they put the word iron bulla. It's okay. So when the halogen react with the iron, so you were able to form this further. We call iron 3. You form iron 3 halide. Guys, what is halide? Halide is the combination of halogen with other people. Example, if let's say hydrogen combined with chlorine, you form hydrogen chloride. If hydrogen combined with bromine, you form hydrogen bromide. If hydrogen combined with iodine, you form hydrogen iodide. So chloride, bromide, iodide, all these further called halide. Understand? When group 17 merge with people, we call them halides in general. Okay? When you combine with oxygen in general, we call oxides. Understand? It's a name. It's just a general name. Now, iron 3 halide, and I want you all to watch out this number. Iron 3. Why is it so important? Because everyone should know, we learned in Form 4 Chapter 3, iron can do a 2 version, right? Fe, 2 plus or 3 plus. Understand? So when they put Roman number 3 means what? We want 3 plus. So watch out. This is a very important one. Come, let's start. Same thing, please use your chlorine to start with your prediction. I start with chlorine. Chlorine is Cl2. Yeah. I react with iron. Iron is Fe. So when chlorine react with iron, can I predict the name? Let's predict the name first before the formula. Iron combined with chloride, I'll get iron. Roman number must be 3. When chlorine merge with any people, the final product called chloride. So I know when iron merge with chlorine, the name is called iron 3 chloride. When I have a name of iron 3 chloride, can I predict the formula? Yeah, right. Form 4, chapter 3. Iron 3, the charge is Fe, 3 plus. Chloride, the charge is Cl, minus Form 4 chapter 3 when the charge is different, cross. 3 go to the right hand side, 1 come to the left hand side, FeCl3. So far so good? Okay? So no need to remember, right? We just predict the whole thing. So now the next one we can balance the whole equation. 1 iron on the left, 1 iron on the right, right? 2 chlorine on the left, 3 chlorine on the right. We learned before in Form 4 chapter 3, 2 and 3. When there is an odd and even number, what do you do? Put a 2. Understand? So we put a 2 here. So let's redo again. So when we put a 2 here, iron become 2, you put a 2 here. Now chlorine is 3 times 2, 6. Now chlorine is 2 times 3, 6. Here, so we have produced another equation again by prediction. Okay? So now what you do here is that, so now can you see why your Form 4 chapter 3 is so important? Here, if you are very weak in Form 4 chapter 3, I'm not saying you can do well, you can't even survive in here. Here, you can't survive in your Form 4 chapter 3 is terrible. That's why your Form 4 chapter 3 is so important. Okay, now the next thing, copy paste. So 3Cl become Br, iron copy paste, 2 copy paste, iron copy paste, Cl change to Br. Yeah, that's it. Same thing, 3 chlorine become iodine, iron got 2 copy paste the 2, copy paste the Fe, Br become I, the 3 copy. Simple as that. Okay, and I want you all to know this iron 3 halide, this fella is a brown color solid. Is a brown color solid. I want you to know this iron 3 halide is brown color solid. Okay, now the last one, how we do the experiment. Okay, the experiment a bit different already. You are no longer like this because experiment number 1 dissolve in water, so got liquid lah. Experiment number 2 dissolve in sodium hydroxide, still got liquid. Now don't have already. Now you are reacting with the iron, with iron. So how are you going to do it? So we will change this experiment a little bit. Let us modify this experiment a little bit. And let's see what is the final outcome. Okay, let me finish it. So this is the concept. So this is the experiment setup. You all must know this is the important concept. Okay. For your halogen, for group 17 to react with the hot iron wool. If you want the group 17 to react with hot iron wool, all the halogen, all the group 17 fella must be converted all the way to gas in the first place. You must become gas. Okay, you must become gas. Without gas, you cannot react. This is a special case. Just now, no problem. Just now, bromine brown liquid, okay. Just now, iodine purple black solid, okay, no problem, okay? But this one cannot. When you want to react with hot iron wool, all the halogen must be converted to the gas in the first place. Okay, let's start with the first guy. The first guy is chlorine. Guys, my question, is chlorine originally is a gas already? Yeah, right? Chlorine is already a gas, so you don't need to do any extra effort. So, you can just put this thing, this whole thing is a combustion tube. It's a tube you purposely use to burn substance, okay? So your combustion tube here, you go to channel in your chlorine gas, okay? Chlorine gas channel in. So inside here, you have some iron wool. This is your iron wool. So this is the iron wool. This iron wool need to be hot. So you need to heat it. So you heat the iron wool to keep it hot. Understand? Alright. At here, you must go to connect with this. I'll tell you why later. At here, at the back, you don't need to know how to draw this picture. Okay? You must go to connect with some special gel. It's a bit like the silica gel in your daily life. This gel is actually called soda lime. At the back here, you have soda lime. This soda lime will help you to absorb all the excess halogen gas. Because you will learn in a short while, guys, for your information, all halogen, all group 17 gases, they are toxic. For information, all group 17 gases, they are toxic. So you don't want the chlorine go in and all the additional chlorine push up to atmosphere. It becomes a toxic gas which we can inhale. Understand? So all the toxic gas, this soda lime will absorb. So none of the toxic gas can go to atmosphere, which is better. So far so good? So this is the first one, huh? Okay, I'll write observation in the short while, no worry. What about the second one? Okay, let's try to go for our bromine. Okay, guys, naturally, bromine appear in what form? Liquid, naturally bromine is liquid. So can a liquid go in already? No, because all halogen, when you want to go in, you must become gas in the first place. So your bromine originally is the liquid, right? So what you should do, heat the bromine, make it become gas first, okay? So over here, you can do something like this. So you can have a tube, you go to another separate test tube. So in your separate test tube here, this one inside you can have some bromine liquid. So the bromine liquid you go to heat in the first place. When you heat the bromine liquid vaporizes and become gas and go in. I feel that. Chlorine no need because chlorine already a gas naturally, so you don't need to do this. So also good? Okay, now do the same thing here. Alright, here you have your iron wool. You heat the whole thing. Same thing. You don't like all the additional gas to go to atmosphere because they are toxic. So all the additional gas they must be collected or absorbed by soda lime. So do the same thing here. So nothing to shout about. Okay, that's it. The third one, no space, go for here. So the third one is here. This is the last one already. Now let's finish it. So the last one is called iodine. Iodine naturally appear as a purple black solid. Same thing, we must make it become gas. Then only the gas can go in to create a hot iron wool. So you must heat the solid first now. Same thing here. Now you go for your tube. So you go for your tube here. So this is your test tube. So your test tube now you have solid. So this is your iodine solid. So the iodine solid is heated in the first place. The iodine solid vaporizes and go in and do the same thing again. Okay? Right? So this is the glass wool. So this is the iron wool and this is heat. Okay? And at the end of the day, all the additional iodine gas is toxic. You shouldn't dump to surrounding. You should absorb it. You should take something to absorb all the toxic gas. So the toxic gas will be absorbed by soda lime. So far so good? Okay, what is the difference in observation? You will see. I'll use blue color to write. So in this case, when you react, you can see the iron wool, they will glows. This one glows. This one iron wool also glows. This case, your iron wool also glows. Okay? But how to show the difference? We know that going down the group becomes less and less reactive. So this one very reactive. Let's write a gas. Maybe brightly. Okay, we can write brightly. So this one maybe less brightly. So what can make the worst thing less brightly for here? Dimly, for example. Understand? Or you can go for very brightly, dimly, no problem. As long as you can show the difference. Understand? Alright? So the iron wool glows brightly because it reacts reactively. This one less brightly, not so reactive. This one dimly, very less reactive. Understand? And what is the final product? When all the halogen reacted with the iron, you form iron 3 halide. And all the iron 3 halide, no matter iron 3 chloride, iron 3 bromide, iron 3 iodide, all of them they are brown solid. Understand? So all of them, you're going to get a brown solid. So brown solid is formed. Brown solid is formed. And last one. Brown solid is formed. So any question so far? Does it make sense to you? Okay, last thing to cover, then we finish with group 17. The last thing is this. Same thing like group 1. You must know your safety precaution. Okay, everyone recap. Group 1 is very, very reactive. That's why we must be very careful. Recall back, group 1 must put in paraffin oil. So group 1, if you want to take it, use the forceps. Understand? Alright, and for group 1, because they're so reactive, use a small piece. Okay, all these things we learned, right? Okay, now, for group 17, what is the problem? Say, there's some space here. I cannot put space here. So this is something called safety precaution. how you going to deal with group 17? Please be very careful. First of all, you all must know what is the hazard or what is the problem caused by group 17. Huh? Okay, group 17, the problem is that they are toxic. They are toxics. Group 17, the problem is that they are toxics. So you should try to avoid direct contact. You don't want to touch the toxic, or you don't want to inhale. Understand? You don't want to inhale the toxic. There are many safety precautions. I think we do 2 or 3 is good enough. Number 1, when you deal with something toxic, of course you must put on your personal protective equipment such as glove, safety goggle. You must put in, okay? Alright? So put on the glove. Okay? Put on the gloves because you must be very careful with it. Second thing, because it's so toxic, you shouldn't inhale. How you want to avoid inhale the gas? Guys, anyone of you here never heard about the word fume chamber? You know what is fume chamber? The part at the back of the lab, that is called fume chamber. What is fume chamber actually? Fume chamber is a place whereby you do the experiment. There's a glass. You pull out the glass, your hand is inside, it's transparent, you do the experiment. All the toxic gas will suck out. So none of the toxic gas will expose to you here because there is a glass blocking in front. Okay? So you can carry out the experiment all the way in fume chamber. Do it in a fume chamber. Okay, third one. Even you put in fume chamber to be secure, please put on a mask so you don't inhale. Okay? So you go to put on a mask so that you can really minimize the chance to inhale. Okay? Guys, why we do all these things at the end of the day? Because group 17 is very toxic. Okay? So you can't afford to inhale it. Okay? Else the person might fail. Okay? So this is why we have to know this. Okay guys, group 17 finish. Okay? This is group 17. Okay? That is what you need to know for group 17. Finish. Okay?